It's a little bit about domain and range on that. I had to remake this. My sound didn't work. So the second thing we want to look at is modeling exponential growth here. Okay, so if you have something that you know grows exponentially, here's how you can model it if you can remember this formula. So y, the amount you end up with is a, your initial amount, times 1 plus r, your percent increase. Now you got to express that as a decimal. So like if r is 18%, you want to put r as 0.18, right? Times the t, time in years. Okay, and I got a little example here I typed up. Let's take a look at this one here. Okay, sorry, it went through this once and it didn't work with the sound, so we'll try this again here. In the last 10 years, an initial population of 44 deer in a state park grew by about 8% per year. Okay, so this thing grows. Let me let that, I actually gave you that to be y. A, the initial population, 1 plus r, the percent increase times t. Okay, so in the last 10 years, so let's take a look at this. 44 deer is what we started out with. Grows by about 8%, so r is going to be that 0.08, and t, our time in years. Okay, so that's the model here, 44 times 1.08 to the t. So we're doing part A here. Now they want us to figure that out for 5 years. So the 5 years, okay? So that ends up being, I actually need to grab my calculator. All right, so 1.08 to the fifth is 1.469. So we got 44, 1.469. So multiply 1.469 times that 44 in front there. You get 64.65 deer. So approximately 65 deer after 5 years. Okay. So part B, we're going to go ahead and graph this. We've done part A, part B. Let's take a look at this graph. So let's say our t is time in years. We'll start at time 0. Go by tens here. We start out with 44 deer. So at time 0, right? 44, whoops, a little under there. 40, a little under 45, right? And we know that at time 5 years, we knew it was about 65, wasn't it? So let me put 5 years on here as well. Let me graph that. We're at about 65. I need to go a little higher, don't I? So 65, okay. So what's this thing look like? Well, it grows exponentially, so we should have a little curvature here to it. So let's plug in 1. So 44 times 1.08 to the 1, and that'll kick out. Just a minute here, get this thing back on. Sorry. 47.52. Punch in 2, 1.08 to the 2 times that 44 in front, 51.322. Punch in 3, 55.427. Punch in 4, 59.862. Let's graph all these points now. So 1, we got 47, a little above that. 2, we got the 51. 3, we got 55. Higher there. 4, we got that 50. So we're about 60 here. No, I didn't do this so great. But anyways, it's kind of like that if I was to draw that a little nicer with some graph paper, right? So that's the graph, the model. Now use this graph to estimate when were there 60 deer. Well, when did you have 60 deer? You know, about, there's was that about right there, right? So about 4 years. You can see it right here easier on the XY table. So after 4 years, we have those 60 deer. Okay. All right, let's look at another one now. Another um, application of exponential growth is compound interest formula. Okay. So here's your compound interest formula. Erase all this again. Sorry that it all went bye-bye when I did it the first time and lost my sound. So anyways, all right, here's your formula for any compound interest problem. So A is your amount you get after T years. P is the principal, how much you start with, the money you start with. And then it's 1 plus, and you got to consider your rate, R. So again, if it's like 8%, that'd be 0.08. Divided by N, the number of compoundings. N is number of compoundings, and T is your time in years. So if your compoundings, oftentimes with like a checking account or whatever, you'll get you'll have a monthly compound. They'll kick back a little bit of interest for you um, each month, right? So that would be where your N is 12. If you have an annual compound, that's just once per year, so N would be 1. If you have a daily compound, then N would be 365. You get a little bit of interest every day of the year type of deal. Okay, and so on. Quarterly, of course, your N would be 4. So let's see if we can figure this out here. So you open up a Roth IRA. When you turn 18 years old, you contribute the maximum of $5,500. And let's say it's in some mutual funds, some stock mutual funds, and you earn the old 10%. That's stock market's average. Annually until age 48. Find the balance after 30 years if the interest is compounded. Okay, so 30 years later, what you going to end up with here? So let's go ahead and fill this in. So what's the principal amount? What did we start with? Our P, we start with $5,500. That's what we first invest. Okay, we get R, our interest rate, 10%, so 0.10 divided by N. Now, initially we're doing it annually, right? So if this is an annual compound, our N would be 1. Divide by 1, and up here to the NT. So N is 1, T our time in years, so to the 30. Okay, so here we end up with 5,500, 1 plus 1.10, so 1 plus 0.1 to the 30. And let me punch that in just a minute. Alright, so you should end up with 17.449 times the 5,500. And that'll kick out 95,971.71. Okay, so almost $96,000. All right. Now let's do that again, but this time let's do it. Let's see, the second part B was for monthly. So since it's monthly, now N is going to be 12. Okay. So we start out again with $5,500. 1 plus the interest rate is still 10%, so 0.1, but it's divided by that 12 N compoundings. 12 times T, we're 30 years. 30 years later, okay? So this is 5,500. Let's go 0.1 divided by 12 and then add the 1 to it. So 1.008 and 3 repeated, all to the 360. So let's take that to the 360. Multiply that number, which is 19.837 times the 5,500 in front, which is 109, 105.697. We'll say 0.70, close enough. Okay, so it looks like our monthly compounding is a little bit better, right, over time, especially with a significant amount of money. Seems to make a difference here. Makes a difference, okay? And finally, let's do it for quarterly. So quarterly would be N being 4. So you just change that to 4, change that to 4, and you can check yourself and work this problem, but you should end up with 106,469.82. That's how much you should end up with for a quarterly amount, okay? So, the rule is, don't go into debt, invest your money wisely, let it grow exponentially, the beauty of mathematics. They call that the magic of compound interest. You guys have a great day. Thanks for listening. See you in class.